Someone say yes. Mega, can you see the screen? Very strange. Mega, I'll ping you the link. Can you can someone of you present, and so that no, I can kind of talk through the presentation. I think somehow the screen sharing is not working for me. And must be some permission. Mega, I'm just sending you the presentation link. It's a web link. Okay, before while the presentation comes up on the screen, we can get started. Like probably I can, kind of introduce myself. Yeah, Meg, I just dropped you an email. Please just bring it up. Okay, I'm sorry, guys. Small technical glitches, right? Great. So hello, everyone. Myself, Manikanteshwar Rao Garlapat. You can call me Mani. I'm a lead strategist with Google. I kind of primarily work on Google search to fight abuse spam. So basically, whatever you search on Google on the search results page, you get so many links, you get so many URLs, so much of information. So maybe they were COVID or something else, right? So my role is to ensure that the page, whatever queries that you search for, you have good results and not spammy results or malware or phishing results within the search results page. So that's primarily my role. I use basically a lot of different machine learning techniques and then a different kind of signals and rules to ensure that Google search is safe for all of us to use on a regular basis. So before Google, I was working as a senior data scientist with Walmart Labs. I was working in multiple different domains. I was working in pricing, supply chain, sourcing, e-commerce, recommendation systems, customer text mining, customer analysis and stuff. Right. Before that, I was working with a lot of research-based kind of roles where it was more into innovation labs to kind of create patents, demo models, prototypes for different clients. Yeah, you can present it. Okay, if you're not able to present, this is a full screen for you. No, on the top there is a small arrow. Just click on that and you can present it. Right side, right, complete right end. There's small. Yeah, now you can present. Yeah, make it full screen. On the right side is present. Yeah, cool. Thanks so much, Shamika, for helping through. Great. So we'll get started. So today's agenda will it's more around different analytics project execution. We'll talk about how a analytics project is kind of set up. What are the different data science steps which are present? How does the analytical problem solving look like? And then we'll talk a bit about how can we fasten up the entire data science space? So like how can you use automated EDA and machine learning to kind of fasten up the entire data science journey? And we'll talk about a particular use case, which is called promotional effectiveness. So basically to determine, okay, how effective a promotion is, what are the price at which a person should sell, right? Like how to understand different customer base. And then we talk about a lot around where the data science is heading, like what is the kind of roles or what is the market look like, what are the skill sets that one has to develop so that they can do great in this data science field. So no more all around all of that we'll talk at the end. Next slide, please. Great. So let's start to understand how does the analytical project basically look like, right? So it all starts with the project understanding. So basically, there'll be you'll have a client, you work with some client, whether it can be internal to the organization or it can be someone outside as well. And you basically, you talk to the client, get a sign of, okay, this is the problem statement I am trying to solve. And this is the data that is available within the organization. And this is the data that I want to procure from third-party sources and then and so on and so forth. So you create a project schedule on data ingestion, data pipelining, feature engineering, what are different models you'll explore, and then what are the kind of output you'll present, whether it's a simple model that will predictive model that you'll share with the client, or is it like a dashboard, or it is kind of a tool where the machine learning model will give certain results and show it to the client, right? So once that project schedule is defined, you start doing a lot of data understanding. Okay, what is the data that I have? That will to address the problem. Say, for example, problem could be like sales forecasting. Like I have like 2-3 years of sales data. I want to see how much of sales will I get. Basis that I can kind of do a lot of mapping in terms of how many resources should I have, what are the kind of things I should plan, right? So that's the problem. So for that, you basically understand, okay, what are the kind of attributes that you have? Is there any external data that can have like climatic conditions? So for example, in Canada, there is like 7 months of heavy snowfall where people don't even go to a shop. They do mostly online ordering and the sales kind of drop. So understanding climatic impact at certain points of time to forecast for the next 2-3 months, even that might be relevant. Okay, I think the screen share short. Just Mega, please check. Yeah. So once the data understanding is done, then people basically look into a lot more in terms of preparing the data, doing a lot of ETL, extract, transform, and load operations to kind of create something called an analytical data set. And you do a lot of quality check of the data, whether okay, all of the data is fine, there are no outliers in the data. So what happens is, for any predictive model, predictive model is something like you have past data, you understand what is happening in the past, and then you use that data to predict what will happen in the future, right? So now all of these data validations, why it is important is for any model to be able to do good, you should have a lot of strong quality data in place. Only then your model you're trying to build will be effective. And then you also kind of do a lot of EDA and data analysis. So EDA is all, it means exploring the data. So how can you slice and dice the data and then try to get a lot of views in what are the relationships between variables, what is the correlations between the variable, what is that is impacting your sales as an attribute, try to understand, so that you kind of shortlist some important features in for your analysis, and then you do the modeling and then insights. Great. Slide 4. Yeah, this slide. Thank you. Project setup. So once you create that entire and have a complete understanding of this entire roadmap, so basically there are 2 stages, which is called the discovery and planning stage, and then there's a design and implementation stage. In the discovery and planning stage, you basically do data analysis, data processing. Like I said, data analysis, you kind of create certain hypothesis. Okay, for sales, then probably number of variety of different merchandise that I have can be important. Whether okay, my hypothesis is that okay, presence of stores in these particular locations will lead to increase in sales, right? So you can create a lot of these hypotheses, and then you can start identifying different KPIs and do a lot of data analysis. And then you also have data processing, where you kind of do a lot of data formatting, data consolidation. You kind of play with the data to ensure you have the analytical data ready for doing a lot of data science work. Now, this data science work is the meat or the core of how good a prediction model that you'll all build. So building the predictive model, deploying the model, checking the performance of how good the model is all part of data science. And we will talk later on like how you can fast track this entire data science part. And then you have environments like if the clients want something like a tool or deploying the model where the different business users can play and forecast and see. So you do a lot of environmental setup, and then you test the environment, you build the reports, establish the different KPIs, and then you publish the report so that the eventual stakeholders can see the reports and then take business decisions quite easily, right? So this is how the entire landscape for a data science project look like. Next slide, please. Great. So let's deep dive into few of the steps and then see what happens at each stage. So you have the data treatment stage. So data treatment stage, what essentially happens is you have multiple sources. So suppose there is customer data, there is orders data, there is more in terms of transactions data or product information, your social media data. Data will be of different places and different locations. You kind of bring merge, do a transpose or append or a roll up on all of these data sources to bring it to one single level. Say, suppose you want to predict whether the customer will churn or not. So it's a customer level data that you have to bring it up. So at every customer, you try to get different attributes like, okay, how many transactions does he make? How much value does he has spent? What is the age? What is the location? What is the household side? What is the income income purchase, what are his interests based on social media presence, right? So these are all the different attributes that you try to get, and then combine all of that at a customer level, and you do a lot of missing and outlier treatment to ensure that your data is all fine, right? And then you have the exploratory data analysis phase, where you basically do a lot of univariate analysis or bivariates or cross types of correlations. So univariates are basically to see a distribution of how it is. So you want to basically see how your customers are distributed across geography, or how what is the income range of your customers. You can probably create buckets and then see, okay, most of my customers are from this particular income range, and you can probably create your product portfolio accordingly, right? And then you can also create bivariates. Bivariates means analyzing two variables at a time. So you can probably analyze household size with spending, like how much spend each customer does. So that you basically see, okay, across two different attributes, how is my sales changing? So you can even cross tabulations is a similar way, in correlations as well give a lot of different insights. Now at this EDA stage, you basically, what you do is you basically create a lot of insights. So you for the customer to address the problem, you basically create certain initial insights, so that it can help answer some of the questions that the client might have. And it also helps in the variable shortlist. So suppose you have like 200 variables to start with, but for the model you need to have the right set of variables in place. Having unnecessary or not so depending variables into the model can bias your model, and then you might not get a good model at the end. So it is always important that you shortlist, do a lot of EDA, identify the right set of variables that needs to be present in the final model, and shortlist them in the EDA phase, the exploratory data analysis phase. And then you start with the model building. And now when you say model building, it's called a predictive model. So basically you're predicting something, what can happen in the future based on some past data. So there are two types of model building that you can do. One is called a regression, one is a classification. Regression model is something that, okay, you have a continuous dependent variable, like you want to predict the sales in the future based on the sales information in the past. So that is a regression problem. Classification problem is something like, say you want to predict whether a customer um, uh, will visit the store or not. It's like a 0 or 1, yes or no. Or you give one other example is that, okay, will it if it rain today or not, right? It's like a yes or no problem. So that's why it's called a classification problem. So there are different algorithms to solve like a regression kind of a problem. And there are a lot of different algorithms for solving classification as well. So you basically decide as a data scientist, based on the data and the problem that you're trying to solve, which model, which algorithm, what are the hyperparameters that you need to fine tune, and eventually get the best model which is robust enough to predict the future for a long enough time, right? So all that is part of the model building phase, and this is the most important one, and this is very much dependent on the previous two phases, like the data treatment and EDA. So if you don't do a good job in the EDA phase or the data treatment phase, then the water model you're going to build will not be robust enough that you will be able to get good results. And then we have the model validation. Okay, so model validation is basically you created something, you created a model, but you want to ensure that the model is working fine or not. So you create a test data set where you have the actual results. And then you predict on that same data set and then get predicted results, and you compare, okay, how close are my predicted results to the actual results. If there is a close overlap, then your model is working fine. If there is very distinct, as in your model is very off in terms of the prediction, then it's not a good model. You kind of reiterate until you get the best model, right? So you might probably want to relook at the algorithm or do some data treatment or EDA, or fine tune the hyperparameter a little more better, and then try to find or optimize the actual minima for your cost function in your model. So it's a lot technical. So you do a lot of things to kind of eventually validate your model. And once your model is finalized, then you deploy that model in production. You create your end-to-end pipeline so that eventually the client can see all of the predicted results. Next slide, please. Great. So now let's see, like I mentioned in the start, that there is certain ways to kind of fast track set of actions that you do. Like for data treatment, there are few methods to fast track certain things, but it's always better that you do this very slowly and precisely without any issues, and not to kind of take some shortcuts. The reason being that until your base data is strong and correct, whatever steps that you take later on will all go off. A small mistake or a small criteria or condition that you kind of make a mistake in the start, then your entire analysis will go for a toss if you don't do it correctly. So that's why take the most amount of time to build and do the right data treatment for your analytical data set to ensure that you get the best data, raw data, or the base data, which sets the foundation for the next steps. And now coming to the exploratory data analysis. So this is more understanding your data, right? So finding patterns from data. So there are a lot of automated methods, right? So I have seen a lot of data scientists kind of doing it manually, spending weeks, like 3-4 weeks to do this, but it's actually a day's work. There are a lot of automated packages that that people are not aware of, and once they use this, they can kind of jet speed the entire exploratory data analysis phase with a few clicks. You even if you're a huge amount of data, you just run the library for an auto run. You put it for run in the night. In the morning, you come, you have all of your results ready for leverage. Some examples are like there's something called bamboo lip, so you can explore it in Kaggle as a GUI interface. So this is very helpful for those who don't want to code but still want to be in data science. So programming is a challenging bit for few. So for them, okay, there are a lot of other libraries which can help you with no coding at all. With just drag and drop of and selecting different variables, you can do all of the data science in exploration data analysis with this. The example that, like I said, the bamboo lib can help you do that. And there is this pandas profiling. So what does this do is it automatically profiles your entire variables, gives you the distribution, summary metrics, patterns, trends, what are the key insights that are coming out of the data that you kind of pass to the pandas profiling library. You get everything in a single report. And there is AutoViz. AutoViz basically helps you to build automated visualizations based on the data. It identifies what kind of visualization is good for which data, and then creates a complete end-to-end report ready for you. Then you have Dora, there's Lens, HoloViews, there's a automated EDA Word doc libraries, and then certain quick visualizations are also present, right? So uh, all of these libraries, you just pass the data and just keep it for run. At the end, you'll have one formatted Word document or a PDF or a presentation ready with all of the insights. You just go through the presentation and then create notes and then pick snippets and put it in your presentation, and you're done with the exploratory data analysis, right? So that's how smart the data scientist should be in now. Gone are the days where you manually say do everything manually or write lengthy programs to do a lot of the things. And now the change in the data science industry is this: how quickly can you do, and how accurately can you do, right? So that is all matters, and how you do doesn't matter. Like, you can use Python, you can use R, you can use Java. There are multiple programming languages now. You have Go. There are multiple languages available. It's all about how well you're presenting and how fastly you're able to get it done. And talking about the model building and the model validation phase, so there is a lot of automation that is happening in these two phases as well, right? So I'll give an example. There are like 100 algorithms, and each algorithm will require optimization of different hyperparameters to get the right model. Okay, so now if you are present and you have a system, and you have to test out all of these different 100 different algorithms for different hyperparameters, it will take 100 days to get the best model out, right? But those days are gone. And even you don't require to know that, okay, this perform will work well for this kind of data, or which algorithm should I use for this kind of data, whether an SVM will work well over a random forest, right? So it's requires a lot of knowledge, inbuilt knowledge in data sciences, and you need to know a lot of theoretical and statistics to be able to address those kind of questions. It is very important, but now you also have the ability to kind of do automated machine learning. So there are a lot of these packages like AutoVica, AutoScaLearn, Teapot, H2O.ai. There's MLBox, Data Robot. So like a couple of them are like few paid resources and libraries, but most of them you have even open source automated machine learning libraries ready to use, ready for consumption, where what you do, you just pass on the data and say, okay, I want a regression or a classification problem, and then you define the time. Okay, you take 24 hours, give me the best model. In these 24 hours, it will run all the 100 algorithms in parallel. It'll try to optimize with different iterations each of the algorithm, and then tries to get the accuracy for all of the 100 algorithms. Whichever algorithm or a combination of different algorithms giving the best accuracy, it will automatically fine tune. And at the end of the time frame, it will say, okay, hey, this is the algorithm. These are the hyperparameters for which you're getting like 98% accuracy, or 92% accuracy, and then it will give you different insights uh, at your hand, ready to use, right? So it's all about understanding, interpreting the results of all of these outputs, and then be able to smartly leverage data science for a lot of things. Next slide, please. If you have any questions, please keep posting in the chat or ask in the Q&A section, and then I'll address them at the end. So need not worry. I'll keep last 15 minutes for addressing any of the questions that you might have. Great. So yeah, so like I said, like the automated EDA and ML, so that is the most important thing to kind of speed up your entire expertise, data analysis, and the machine learning phases. These I have listed few, but there are a lot more. There are a lot of paid tools in the machine learning space, and I can even give you certain example. Even all of the cloud platforms like AWS or GCP or Microsoft Azure all have a lot of inbuilt machine learning capabilities. So you just have to create different connectors for different data sources that you have. You just add a node, say that, okay, do automated machine learning, and then you just give in different inputs in the user interface, create that pipeline, and keep it for run, and automatically you'll have all of the outputs ready, right? So these what I have shown is a few examples for you to get started, but there are a lot of other packages, libraries, and resources ready for your consumption. Next slide, please. Okay, so let me spend some time on a use case, so that you understand, okay, how does data science look like? What is a day of a data scientist look like, right? So that you understand, okay, what are the problems that the data scientist will solve? How much of data and what pre-processing happens? So I'm taking a very popular use case in the retail industry, right? Every retail company, one important thing that they need to do is they need to give promotions to attract customers, and then they need to evaluate whether the promotion is effective or not. So what happens if you give more discounts? You might go go into losses, and sometimes you might give enough discount that it can be lower than the cost price, so that you can increase your sales, and then customers might like the product and come back again and again to buy over time, right? So there is a lot of things that go into promotion planning. Now one major problem is for a retail is, okay, I gave 100 promotions, different promotions last year. What are the promotions that I should repeat for the next year? How much discount should I give? Whether should I give 5%, 10, 15, 12? What is the optimum percentage that I should roll out for which category? What customers at what time in a year, and for what categories of the products should I give a promotion, right? So there is a lot of variables and lot of scenarios that are possible, and we'll talk about this promotional effectiveness, how it is usually typically solved, what are the kind of challenges that are present. So let's try to understand what is the data that is required in order to able to address the promotional effectiveness. One, you need to have promotional data, which is more in terms of multi-save, like, okay, buy 3 get 1 free, buy 2 get 1 free, or you have something like a legacy information like rollback, temporary price reduction. Rollback is like $10 is being given for $9.5. They roll back the price so that not attract customers. And then you have different visual promotions, like you give flyers, digest or coupons, or send emails to different customers, right? Or you can put certain posters at different places for different categories. And you have different pricing strategies that are also present, like which category, which item, which price is being sold at. And then you have some out of store, like like more like digital, like social media campaigns or marketing campaigns data. And you require competition data. Okay, how much price is for this item is being sold by Amazon? How much price for this item is being sold by Target? What a same item might be sold by different competitors at different prices, right? So you need to ensure that is it competitive enough. And then you need to know the pricing details, and then there's something called markdown data. Like markdown is like sometimes certain items might be damaged and you might have to mark it down to ensure that they are sold well. And then you have to have cost data. At what price did I buy this item at, and what are is any discounts, is what is the shipping cost, and so and so. And then you have require the order information, like, okay, the transaction details of the customers for different items. And you combine all of this data at item level in order to be able to identify, okay, this particular promotion is effective or not. Next slide, please. So this is the entire analytics workflow, or how does it work? So you basically take this promotional data, the multi-save data, and then the next two data. So like I have written is an example, like where certain retailers might require climatic information. Like I took an example of Canada, where you have 7 months of snowfall. So even climatic information is very important to kind of seasonalize your sales by different weeks. And then you need holidays data, because typically in a retail, when there are holidays, there'd be a spike in sales, right? So you need to kind of de-seasonize the sales by adding these holidays as different attributes into your analytical data set. And once you have your analytical data, you do promo tagging to basically say, okay, these are the time frame when there was a promotion for these particular items, and you create flags. You basically say, okay, this was a promotion, there was no promotion. And then you kind of basically calculate few metrics called pull forward or return trip halo. So pull forward is something like, let me give certain base examples, right? Like there is halo, cannibalization, and all of these things. So let me start with halo. So whenever you put an item on promotion, what happens is a similar item sales can increase. For example, you put bread on promotion. What happens? People will buy bread more. Along with bread, they might tend to buy butter, jam, at an additional thing, even though that is not on promotion. Right, so that is called a halo effect, where increase in sales of non-discounted items tend to increase, right? So that's called halo. Now you can have cannibalization because you put bread of a particular brand on promotion. Brand B sales, which is not in promotion, will decrease because it's eating away the sales of a promoted product, right? So the canvas. So similarly, you have retention parallel. Like you put an item on promotion, people like that item. Even after 4 weeks, when there is no promotion for that item, they tend to buy the same item. So you are kind of increasing the sales of that item in a way, right? By giving a promotion. So all these are the effects of a promotion because you gave an item on promotion. They could be halo, they could be cannibalization, they can be return trip halo. All of these the different things needs to be calculated together, and for each thing you need to do something like affinity calculation or a substitution calculation, and then do all of these calculations and stuff, and then sum it up to eventually able to get the net lift. So that net lift for each promotion is what you will have to compute. And if the net lift is positive, you basically say, okay, my promotion has been effective because it has overall created an increase in sales for that particular category. If it is negative, it can happen because cannibalization is more than halo and iterative halo, and your net lift can be negative. So you don't repeat those kind of promotions because you'll be in losses because the promotion wasn't turning out to be an effective for you for that particular category, right? So that's how you basically compute for different promotions what is the net lift, and eventually take decisions and create recommendations for your customer that, hey, these are the right set of promotions and these are the other set of kind of net lift for each. And then this is, if you do this kind of scenario, like if you combine a discount of 5% with a flyer on for this particular product, this is the possible net lift that you can get, right? So you can basically build a scenario planner at the end and then give it to different category and pricing managers to basically plan out marketing and pricing strategies for all of the products. So that's how using data science and knowing a lot of domain in terms of how promotions work. No, you should understand what is halo, cannibalization. These are all domain specific things. So that's why data science is a mix of algorithms, understanding different predictive models, understanding the domain, and a bit of programming and tech so that you can encode all of these together into a working pipeline. Next slide, please. Great. Next 5 minutes, I'll talk a bit about future of data science, and then I'll open it up for questions. So where is data science heading, right? That is important key. So as I mentioned before, like 10 years back, we didn't have so much of tech. There was no automated machine learning. There was no automated EDA. Now we have so much of open source libraries that is present that you can do a lot of things in clicks. Now most of the problems are like solved. You don't have to start from scratch. Say, for example, telecom churn. There are thousands and thousands of data sets, and all of the data is available in GitHub or somewhere. You can simply leverage it. You don't have to start that problem from scratch, right? So, but where is the time is being spent now is on natural language processing and deep learning. So these are the two areas which are still niche, and people are researching to kind of improve and then get good results. So just few days back, Google announced achievement by DeepMind. So human protein genome is now like 35% explored. It took 17% for 50 years for the community to kind of identify the genome structure, but DeepMind was able to double that knowledge over a night. It took one single day to kind of process it, to double the knowledge that we have for a human genome, right? So that is the power of data science. So we are going far ahead to basically understand human genome, understand how different diseases affect human beings. All of this in the health space, machine learning is helping. So this is the latest breakthrough by Google DeepMind, which just published like a few days back, right? So there's so much of advancements that is happening. Again, in natural language processing, you have we started to have like word vectors. Then there was BERT 1.0. Now we have BERT 2.0. Now there is so MUM models, which was recently announced by Google. Right, like there's a lot of improvements in the natural language processing side that is happening. Now we are able to understand the context of what the customer wants, and then eventually give them the relevant data and insights. Right, so that's where it is heading, and where a lot of research is happening, and a lot of things have been automated. So right, it be like creating data pipelines, or building different features, or working with different APIs. So API are the three-tier technology of how a product is built. Um, uh, every model is now being used as a self-service API, where you can just call an endpoint of an API, it gives a result. So you just pass the text to the API. Even if it's a very complex model which is run by someone, you can just pay some amount and then get the sentiment of that with a simple line. Right? You don't have to build. So these are all like ready to use APIs are present for solving anything or getting any information. So that is now a key for data scientists to be aware of, and leveraging models as a service, and knowing a lot of ready to deploy frameworks, like how does Dockers work, or how to work on cloud. Right, so they are ready to deploy frameworks and tools, so that you need to be aware. And cloud, yeah, like a lot of data science is being moved to cloud, because organizations are doing that shift from legacy systems to cloud. So it is eventually important that you also know how to work on cloud platforms, right? Because now if all your data is available only on cloud, then eventually you should know how to work on cloud, how do you access it, what are the kind of things that they can be leveraged, how can you build automated data pipelines on cloud. It all helps, right? So that's pretty much it. I'm done with the webinar. I will open it up for any questions that you might have. Would be glad to answer. Any questions? Probably we can do a quick poll to basically understand the audience, like what are your interests, or if you have any questions, please free to post in the Q&A section or in the chat, and I'll take it up. I'll give like a minute for you to post any questions, or else I have a few more things to share in terms of how can you do career transformation in this field. Okay. Any questions? I have one question. Sir, what exactly we can expect from this course? Great. So this is a very intense program. First thing, it goes deep into different statistical concepts. So if you're aiming to become a data scientist, or a machine learning engineer, or a technical program manager for data sciences, right? Data science is a very, very good field. In next 15 years, it's going to be peak. There's going to be a lot of demand, that's for sure. So you will be able to clear any of the interviews that for if you're going for any of these roles, right? So this is not like a theoretical subject where you just kind of understand, okay, what are the concepts in data science and stuff. This is more of a practical learning. So that's the reason there'll be faculty coming from different places. One like me, I'll take few of the courses in this program as well, to teach industrial, to bring in industry relevancy, right? So my or most of the industry experts thought process would be kind of to ensure that you'll be able to crack any interview at ease by able to do this course. And you should also be ready to and skilled enough that you'll be able to solve any data science problem in any of the industry without any difficulty. And you are able to, so what is happening is, over every 3-4 years, a lot of things are changing. Fresh university graduates are coming with a lot of new knowledge, but old like people who kind of been from the past of like 10 years in the industry, they tend to not be able to keep up pace with them, right? So this course ensures that you have all of the latest tech in data science, latest advancements in data science, like BERT 2.0, or deep learning, computer vision, natural language processing, recommendation engines, fuzzy logic. There's a lot of things that is happening in across the different industries. You will get to know a lot of case studies, capstone projects. You work on live data. So it's like an end-to-end of data science given to you in a 2-year time frame. Very intense. You will, and if you are able to crack this course, I'm pretty sure you'll be able to crack any data science interview very easily. I'll go to the next question. So if suppose if anyone is not from tech background like computer science, etc., so any graduate can do this course or not? Very interesting, nice question. I get this question a lot. So I'll give you guys my scenario. I am from bachelor's of pharmacy, so I did B pharmacy, and then I became a data scientist. Right. So whatever background you are from, so B pharmacy is not even close to civics or mechanical or E&I, right? There's a little bit of programming there. I didn't have any programming yet, but I had an interest and passion to become a data scientist. I had interest to learn programming. I wanted to kind of get into this field very badly. I had the passion and rigor. So that is important. If you have that, how complex ever it is, you'll be able to solve. And programming, when I say, it's not the programming that engineers do, like a software developer will do, or an Android or a iOS developer does in Java. This is like simple 2-3 lines of script. So there'll be libraries, and then you just have to know only 3 or 4 libraries. There are like thousands and millions of libraries for a lot of things. You need not know that. That is not relevant for you. There will be dedicated engineers who will do that. You will have to learn few simple libraries which are necessary for data science. So even I think you can definitely pick it up, buddy. I did it, so anyone else can definitely do it. Next question. Data science is domain centric. Functional knowledge in specific domains like energy, telecom, retail, etc., has to be acquired only from traditional industries. How to merge the thinking of emerging industry and traditional industry? Interesting question. So every industry is going through a transformation journey. Right now there is industry 2.0, 3.0. There's changes in how it is, things are happening. I recently worked for a glass manufacturing company. The glass that they create, they are the world number 1 glass manufacturing company, and now they are leveraging analytics. They're starting with the digital journey, trying to kind of for some use cases, I'll tell you, how do you monitor the health of different equipments that are present? How do you monitor the kind of rate at which glass is getting created versus to meet industry demand? How can I forecast the prices of glass across? How can I listen to customers and then kind of respond, right? So every industry is going through that. So now, how do you need to merge the thinking? Is it will be more in terms of understanding traditionally how businesses are being run, and then try to kind of see what is happening in the emerging industries, the similar space, and try to slowly upgrade yourself. So if you are going to still be traditional, then you'll be beaten up, and then you'll be outrun by other emerging industry. So you should always keep up your pace. Even myself, I have to learn a lot of things on a monthly basis to understand and keep up myself with what is happening in the industry trends, right? Or else there'll be new fresh graduates who will outrun you. You need to always upgrade yourself and then keep learning newer things. So that's the mantra that I think all of you should definitely need to follow. I'll move on to the next question. Currently, I'm working as a data science consultant in a retail company. Great, you are in this data science industry already. I want to enhance my knowledge in deployment and deep learning techniques. Does this course make sense for me? Very nice question. Yes, it's definitely perfectly suited for you. So this is for beginners as well as for advanced folks already who are in data science side, but who don't work in computer vision, NLP, or deep learning spaces, or who doesn't work on production deployment a kind of case, they might not have knowledge, and they might fail in clearing data science interview for other companies. So for it perfectly suits you, and actually you'll have edge over few of the folks, because it might data science might be complete new for them. But since you're already in this field, you already know a lot of things, it'll be like easy, a bit easy compared to others. And yeah, it's very much suited. It goes deep into different concepts of deep learning, big data, cloud technologies. So it definitely makes sense for you to take up this course. I have one last question, sir. How will working profession cope up with this course? Yes. So this is an intense program, right? But you need to free up at least 3 hours or 2 hours per day, or every day if you're not able to get time, at least over the weekend, spend 5-6 hours for this program. I think that is sufficient. Right? This is very intense, but most of the things will be new for you, so you will take time to learn. But as you learn one of the topics, right, you will become so much engrossed, and you will love this course so much that you will feel like spending a lot more time. So in my initial career days in data science, I used to spend like 18 hours at a stretch. I used to like continuously be like, for 2 days I slept in the office, because it was not that the company was asking for it, because I wanted to work for it. Because data science is such a fascinating field, because you work on different problems, new problems every day. You fight with a lot of challenges, things, and you never feel like, okay, I'm slogging myself so much in this field. Is it worth? You yourself will feel like, because you'll start loving this field. So I think if it is a little hectic, but you yourself will start liking it. When you like it, like a particular thing, you will never feel that, okay, you're spending so much time for something like this course. Okay, I have one last question. I'm looking for AI/ML, and I'm having 14 years of experience in cybersecurity. Would this MSD help me to change my current profile to AI/ML? Very nice question. So cybersecurity, right? So it's very important field, and you have a lot of domain knowledge already. So what you need to do, because you're already 14 years in this career, you will basically need to kind of leverage analytics to kind of uh, do a lot more in your current domain. You need not transition into a new field, but you can still continue to be in the cybersecurity space and start kind of using AI, ML, whatever you're learning these, try to apply these techniques in your field. And then as a manager, or as you grow in the organization, you'll be able to do wonders. And I think there's one last question. So, sir, after completing this 2 years course, can we probably call as master's degree in AI/ML? Where yes, you can definitely call, because it's a recognized program, and you can definitely call yourself that you're done a master's degree. And there are very few universities who offer a master's program in AI/ML. They are mostly like PG diplomas that are present, but this is one of its kind, which is a master's program. Is it UGC and AICTE approved? I'll ask the NMIMS team to answer that. I'm not very much sure of the nitty-gritties. I'm a faculty for this program, right? So I might not know. Subhadip, please reach out to someone from NMIMS. They'll help you answer that. After gaining years of experience, we land in our dream company like Google. Okay, this course is only focused in data science or AI related as well. Very nice question. So, okay, if you are targeting the tier one companies like Google, Microsoft, Apple, LinkedIn, Amazon's, so these are tier one, right? So now, if you want to go there, how you have to do is you need to create a phased approach. So I couldn't directly land in Google in the first time. So I had to create like 7-8 years. I have to be in the industry, learn, create a lot of domain knowledge, expertise, and create myself as a machine learning expert. I should establish myself, and only then I'll be able to crack different interview rounds for data scientists for some of these tier one companies. So yes, you need to kind of at least spend 5-6 years, learn different industry things. Start with service companies, like there are a lot of these service based companies in analytics, like TCS or Mu Sigma. There is Absolute Data, Latent View. Start with these service based companies, understand the landscape better of what, where, how data science is used in different industries, get that knowledge, understand different algorithms, and then move to a product company. That I think that transition will help you in the long run. And I think it worked very well for me. So it will work definitely for others. Okay, I will take this one last question. So, sir, how will be the practical hands-on done in this course? I meant it will be done via training or recording. Great. So it will be in live sessions, definitely. So even like Python programming or any of the topic which we take, the faculty will teach you in live how to by writing the code and then show you step by step. Okay, this is how it is being done. And yes, this session will also be recorded. So people who will miss the live sessions can at ease look at the recording, and then come there'll be forum. If you have any doubts, you can post in the forum, and then there'll be people who will be addressing your queries. So you need not worry. It will be live and it will go very hands-on, and that's the reason it's a mix of university and industry experts, right? Like for topics which are more theoretical, the university professors are well suited because they can teach you the concepts very deep. But to keep yourself ready with the industry knowledge and relevant, then you need to have industry experts also available, right? So so people like me will come in and then teach you a lot of the theoretical concepts that you've learned. How are they being used in industry by showing you case studies, and when going step by step executing programs and then deploying everything. If you're learning on Hadoop, then we show you how do you install a Hadoop cluster, how do you work on the data, how do you query the data, get the data, and then process it, and then build a model, deploy it end to end. So it's not just a theoretical program; it's more hands-on as well. And that's it. We are no more questions. I'm so sorry. If you have any more questions, reach out to the NMIMS team, and they will help you address. And if there's something, if my inputs are required, I'll ask them, and then they'll forward answers back to you. And I wish all the very best to each and every one of you. And please do share feedback on the session on how it is. If there's something that you've liked it or something you didn't like and you want something more to be covered in future sessions, it'll help. And one only thing that I will share is that data science is a very, 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 very rewarding career versus any of it. I myself had tried, I was an Android or iOS developer for 3 months. I was a web designer for 4-5 months. I was part of a BPO. I started the banking industry. I tried everything. I never liked it, but data science was very interesting. And in terms of pay growth, the kind of interest that I had, it is unparalleled and unmatched. And there is a lot of potential for it. Whatever decision you guys take, whether you take NMIMS or any other university or any other program, but be ensure that you are going the data science field, and one day you will thank me that okay, that you have made the right decision, right? Great. All the best, very best to each and every one of you. I hope all of your career transitions come true, and all the best. Take care. Bye.